everyone, and welcome to the FreeNAS YouTube channel. In this video, we're going to give an overview of creating pools after installing FreeNAS. To begin, we are going to create a pool so storage disks can be allocated and shared. Head over to Storage and then Pools. This window lists all pools and datasets currently on your FreeNAS machine and will not have any entries until you create a new pool or import a previously created pool. Click Add to create a new pool. The Create New Pool option allows you to form a pool from available disks. The Import an Existing Pool option imports a previously created pool. Create a pool now and give it a name. Note that there are some restrictions on what you can use in the name. Refer to the link and additional information in the description of this video. I will call the pool I just created My Pool. Encryption can be used to protect sensitive data when removing a disk from your system. Encryption must be managed very carefully, as you can potentially lose all access to your data if you forget the passphrase or lose the encryption keys. FreeNAS uses the open source version of ZFS called OpenZFS, which provides its own redundancy implementation known as RAIDZ. ZFS also offers simpler disk configuration, like mirrors or stripe. ZFS is known for its unprecedented flexibility and uncompromising data integrity. In ZFS, drives are logically grouped together into one or more virtual devices, or VDEVs. Each VDEV can combine physical drives in a number of different configurations. If you have multiple VDEVs, the pool data is striped across all the VDEVs. It's also important to note that if any one VDEV in a pool fails, all data on that pool will be lost. Make sure you have enough redundancy built into your pool if you can't afford data loss. Suggest Layout attempts to automatically choose an ideal VDEV layout for the number of available disks to balance usable capacity and redundancy. The following VDEV layout options are available when creating a pool: Stripe, which is similar to RAID 0, Mirror, similar to RAID 1 but not limited to 2 disks, RAID Z1, similar to RAID 5, RAID Z2, which is similar to RAID 6, and RAID Z3, which uses triple parity and has no RAID equivalent. The first VDEV option is Stripe, which simply combines all the disks into one single volume. A striped pool provides the best performance and most storage. However, since there is no redundancy, the failure of any disk will result in the loss of all data on the pool. Mirroring, like RAID 1, duplicates the data across every drive in the VDEV. Because the pool data is striped across all the VDEVs, a pool with multiple mirrored VDEVs behaves sort of like a RAID 1+0 array. This setup has excellent redundancy and performance. As long as the mirrored VDEV has at least one functional drive, your data will still be intact. Since the same data is on every drive in the VDEV, read operations can be divided between all the drives. Write operations still have to go to every drive in the VDEV, however. Mirrored VDEVs do come with their setbacks, though. It has the highest capacity penalty of any VDEV configuration. For example, to get 10 terabytes of usable space in a 2-drive mirror, you would need 20 terabytes of drives. RAID Z1, which is similar in concept to RAID 5, offers a higher capacity while maintaining a layer of protection for the data. RAID Z requires at least 3 of the drives, where the VDEV will add 1 disk's worth of parity data, but distributes that parity data across all the drives. While RAID Z1 does offer more protection than a simple stripe pool, using RAID Z1 is generally discouraged. As individual disk capacities increase, resilvering or rebuilding an array can take several hours. The resilvering operation puts a high load on the disks, and if you're using RAID Z1, if any disk in the faulted VDEV fails during resilver, the whole pool will fail with it. Because RAID Z1 is vulnerable to total pool failures during a resilver operation, we typically recommend using RAID Z2 for backup and file sharing configurations. Similar to RAID 6, RAID Z2 adds a second set of parity data to the VDEV, again distributed across all the disks. You can lose 2 disks per VDEV while maintaining data integrity, meaning RAID Z2 is safer than RAID Z1, but has a greater capacity penalty. RAID Z2 requires a minimum of 4 disks. And finally, RAID Z3 adds a third set of parity data to the VDEV. It requires at least 5 disks, but allows you to lose up to 3 disks per VDEV without any data loss. For this build, I want a lot of capacity to store my music and photos, and I don't want to risk losing my data, so I will choose RAID Z2. For additional information on ZFS pools and how their configurations can affect performance, see the blog in the link in the description below. A hot spare is a drive that isn't used for storage, but instead will immediately replace a failed drive in the pool. Because the pool is most vulnerable while it's in a degraded state, i.e. it has failed drives but is still functioning, it's very important to begin the pool resilver operation as soon as possible. Having a hot spare in the pool ensures that this operation will start immediately, so it's highly recommended to have a hot spare in your pool if you have space for one. After you've selected a VDEV layout, click Create to continue. You should now see your newly created pool listed there. Thanks for watching this tutorial video. For more information, visit ixsystems.com to learn more about FreeNAS and our company iX Systems. Don't forget to check out our other tutorial videos and like and subscribe for more FreeNAS content. FreeNAS is the open source community edition of the iX Systems TrueNAS product family, a comprehensive line of powerful unified storage products for organizations of all sizes. With its flash-based architecture, powerful ZFS file system, and award-winning support, TrueNAS systems provide secure, scalable, and flexible high-performance storage for virtually any application and budget. To learn more about the TrueNAS product family from iX Systems, visit us on the web at ixsystems.com.